All right, 8th graders, we are in section 10.3, covering formulas in 3 dimensions. So we're going to start talking about a polyhedron. A polyhedron is formed by 4 or more polygons that intersect at their edges. Prisms and pyramids are polyhedrons, but cylinders and cones are not. Make note of why they're not, because a cylinder, if you unfolded it, the net would consist of 2 circles and a rectangle. Well, that's only 3 polygons, not 4. So a polyhedron is when you have 4 or more polygons that intersect only at their edges. So here are some examples of what a polyhedron would look like and what something that is a solid but would not be a polyhedron, what they would look like. All right, so Euler's formula. Now you're probably looking at that going, that doesn't say Euler, it says Euler. The correct pronunciation is called Euler. Euler's formula is used to show the relationship between the vertices, edges, and faces of a polyhedron. So here's what it says. If I take the number of vertices and I subtract the number of edges and then add the faces, you will get 2. So, example 1, using Euler's formula. So I want you to find the number of vertices, edges, and faces of each polygon, and then use your results to verify it with Euler's formula. So, vertices. If you count up the number of vertices, 1, 2, 3, 4. So we have 4. Edges, 1, 2, 3, 4, 5, 6. And faces, 1, 2, 3, 4. So if we use this in our formula, number of vertices minus edges plus faces, will that equal 2? That does work. 4 minus 6 is negative 2 plus 4 does give me 2 equals 2. That does work. Let's do it on the next one. The prism, the pentagonal prism. Vertices, 1, 2, 3, 4, 5. There's going to be 10. Edges. That would be 1, 2, 3, 4, 5. The other side is going to give us 10, 11, 12, 13, 14, 15. And faces, 1, 2, 3, 4, 5, 6, 7. There's going to be 7. If I plug that in, 10 minus 15 plus 7, will that equal 2? Negative 5 plus 7 is 2. So you're going to use Euler's formula to verify if you did this correctly. If you didn't do it correctly, it wouldn't work out. The next thing we're going to talk about is about the diagonal of a 3-dimensional figure. So the diagonal, represented here in red, D, so the diagonal of a 3-dimensional figure connects 2 vertices of 2 different faces. Diagonal D represents that. Now, diagonal X is not that because it's only on one face. So by using the Pythagorean Theorem, right here, you can use L squared plus W squared equals X squared, and then using X squared plus H squared equals D squared by substitution. So basically you're finding if you're looking at the bottom to find the diagonal, you can use Pythagorean Theorem to find X, which is the hypotenuse, and then once you find the hypotenuse, you're going to use that as a leg to find the diagonal, which is the hypotenuse of the vertical triangle. So by substitution, we have a shortened formula. So the diagonal of a right rectangular prism can be used by using, now once again, if you look up here, it says d squared. So to get rid of a squared, you square root it. You would take the length squared, the width squared, and the h squared, the height squared, find the sum of those, and then take the square root, and that would give you the diagonal of a right rectangular prism. So example 2, in A, find the diagonal with lengths 3 inches, 4 inches, 5 inches, or dimensions, 3 inch by 4 inch by 5 inch rectangular prism. So if I plug that in, D equals the square root of 3 squared plus 4 squared plus 5 squared. Well, that gives me the square root of 9 plus 16 plus 25. That's the square root of 50. So you can leave it as root 50, or I would approximate it as 7.1 inches. When we're talking about length within a problem, you more than likely would usually take the square root to give me an approximated decimal. Next up, find the height of the rectangular prism with an 8 by 12 foot base and an 18-foot diagonal. So we're going to plug that in. 18 equals the square root of 8 squared plus 12 squared plus h squared. We're going to square both sides to get rid of the root. So that gives me 18 squared, which is 324. And that would give me 64 plus 144 plus h squared. 324 equals, well, the sum of 64 and 144 is 208. I subtract 208. That gives me h squared equals 116. And if I take the square root of 116, that gives me approximately 10.8 feet as the height of the rectangular prism. The next thing we're going to talk about is space. Now you're like outer space? No. Space is the set of all points in 3 dimensions. 3 coordinates are needed to locate a point in space. A 3-dimensional coordinate system has 3 perpendicular axes: the x-axis, the y-axis, and the z-axis. Instead of ordered pairs, we're now going to use ordered triples, x, y, z. To locate the point, now we start at 0, 0, 0, and to locate the point 3, 2, 4. Here's what it looks like. Now, this is kind of confusing. Your x-axis looks like this. Your y-axis looks like this. Now, if you can visually think of it this way, this x-axis and y-axis is the same as this. It's in one plane. But I've now taken this and I've flattened it out and rotated it this way. So this right here is still 90 degrees. These two are the exact same thing. We're just looking at them at different viewpoints. So the z-axis is now going to be, we're going to write it where it looks like vertical. And everything here forms 90-degree angles. Now, to graph it, 3, 2, 4. So 3 is how many out from the x-axis we go. So in the front, these are positive. Back is negative. So we go forward 3 for the x-axis, right 2 for the y-axis, and up 4 for the z-axis. So this point, 3, 2, 4, is the ordered triple that we just graphed. So example 3, we're going to graph each figure. In A, we're going to graph a cube with an edge of length 4 units and one vertex at 0, 0, 0. So I'm just going to draw the picture. It's going to be easier to explain it. Every side, you're going to go 4 different ways to find the cube. So here's our picture. 0, 0, 0. That means we're going to go 4 this way, put a dot. 4 to the right, put a dot. Out 4, right 4, put a dot. So you'll notice everything is 4. All four units would be all the edges. So all of the ordered pairs would be here, or I'm sorry, the ordered triples would be 0, 0, 4, 0, 4, 4, 4, 4, 4, 4, 4, 0, 0, 4, 0, 4, 0, 0, and 4, 0, 4. It's easier to get these after you actually draw your picture and go from there. Now, you could have also gone to the negative side, but it's easier to go to the positive side. Part B, graph a cylinder with a radius of 3 units, height of 5 units, and one base centered at 0, 0, 0. So I'm going to draw the picture. If the base is at 0, 0, 0, we can let that be the center of the circle. So the center of a circle, now this isn't going to look like a cylinder to you. It looks more like an oval, but it's not. This is a circle. So you'll notice here, 0, 0, 0. The circle is centered. The radius is 3 units, so I go out 3 all directions. 3, 3, 3, 3, and I draw my circle. The height is 5, so you're going to count up 5. So you can all you need to do is take your center, move it up 5, put another center, and go out 3, 3, 3, and 3, and then connect them. And you've just made your cylinder with a radius of 3 units on a height of 5 units, centered at base at a point 0, 0, 0. Now you've used the midpoint formula before. We can now find the distance between 2 points, x sub 1, y sub 1, z sub 1, and x sub 2, y sub 2, z sub 2, by drawing a rectangular prism with the given points as endpoints of the diagonal. Then use the formula for the length of the diagonal. You can use the formula related to the distance formula, which is in section 1.6. The formula for the midpoint between these two ordered triples is related to the midpoint formula. So here I want you to write this down. How do you find the distance and midpoint formulas? Well, you're going to use this. You're now going to subtract your x's and y's and your z's. All you're doing is adding another number that you're adding, and that's subtracting your z's and squaring it. The midpoint is the same thing, except now we add our z values and then divide by 2. So example number 4. Find the distance between the given points and find the midpoint of the segment with the given endpoints. Round to the nearest tenth. So let's first find the distance. The distance would be subtracting your x values. So 3 minus 0 gives me 3 squared. Plus 4 minus 0, subtract your y values, 4 squared. Plus subtract your z values. That'd be 12 squared. So that would be 9 plus 16 plus 144, which gives us 169, and the square root of 169 would be 13 units. So the distance is 13 units. Now the midpoint. The midpoint is adding them, taking half. So we add our x values, that'd be 0 plus 3, divide by 2. Add y values, 4 halves. Add the z values, 12 halves. The midpoint is going to be 1.5, 2, 6. So the ordered triple is 1.5, 2, 6. And the distance is 13 units. Why don't you try this one on your own? Pause the video, see if you can find the distance and the midpoint rounded to the nearest tenth. If you did this correctly, you would find that the distance is approximately 7.5 units, and the midpoint is 5, 10, and 12.5. In our last example, we're going to use a real-life application. 2 divers swam from a boat to the location shown in the diagram. How far apart are the divers? Now, here's the thing. This is not just on a plane. You'll notice that the depth of each diver is different. So we're actually in 3 dimensions here. So what we'd have to realize is we'd have to find the ordered triple. So if the center of the boat here is 0, 0, 0, we could say this diver is at a depth of, we could do negative 15, negative 6, and negative 12. This diver up here goes the opposite direction, so they're positive. So that would be 18, 9, and negative 8. Now if you're wondering, well, how do I get which number goes in what ordered triple location? It doesn't matter. Because when you actually put it in your distance formula, it wouldn't matter what we're going to do. But notice the last ones are both negative 12 because both divers went down. So now, let's plug it into the distance formula. Subtract the x values. Negative 15 minus 18 would be negative 33 squared. Plus, negative 6 minus 9 would be negative 17. No, that would not be negative 17. and that would be negative 15 squared, plus negative 12 minus negative 8. Well, that's negative 12 plus 8, which would be 4 squared. If I added those up, 33 squared, or negative 33 squared, plus a negative 15 squared, plus 16, that would give me the square root of 1,330, which gives me approximately 36.5 feet as the distance apart. The vocab words I want you to know are space, an ordered triple, and a polyhedron.